In our world, nothing ever truly ends. When we die, our bodies return to the earth, feeding new life. In that sense, a part of us goes on. But what if, one day, there's no after at all? Modern physics suggests that this haunting idea could come true. That time itself might end. No more tomorrows, no more recoveries. Just an eternal freeze. Before Einstein, time was seen as a steady beat, a universal clock ticking without pause. But his theory of relativity revealed a deeper truth. The universe is not a machine. It's a cosmic symphony. And time? It's not constant. Time bends. Time slows. Time stretches in the grip of gravity. When you drop something, it's not just falling. It's racing toward a place where time moves more slowly. So, what happens when even time runs out? Time doesn't just pass. It dances. Like musicians improvising a jazz set. Time flows, twists, and reacts to the world around it. But sometimes, that rhythm collapses. Like a drummer who plays too fast, too hard, and burns out. These cosmic burnouts are what scientists call singularities. They aren't just extreme moments. They're boundaries where time itself hits a wall. The most famous? The Big Bang. Around 13.7 billion years ago, time burst into being with a roar that shaped everything. But what if the song ends? If the universe stops expanding and begins collapsing, we may face a big crunch, the reverse of the Big Bang, a moment where time folds into silence. Yet, not everywhere. Inside black holes, time does end. At least from the inside. Out here, it continues on. But, if you fell into one, you wouldn't just be crushed. You'd be torn into atoms. And time, for you, would simply stop. What if time simply vanished? Not a peaceful ending, but a total collapse of everything you've ever known. There's a place, a point of no return. They call it the singularity, where time itself comes to a stop, where nothing is reborn, where existence dissolves without echo. You wouldn't just die. You'd be erased, like a sentence never completed. And here's the chilling part. It was Einstein's own theory that predicted this fate. No salvation, no cycle, no way back. That's why scientists today are chasing a dream. To merge relativity with quantum chaos. To build a theory of quantum gravity, hoping it might erase the singularity. But what if time never ends? Would that be even more terrifying? Long before Einstein, philosophers battled with the same question. Kant called it an antinomy, a paradox with no right answer, leaving us adrift in doubt. So what do you think? Would you rather see the end, or live in a loop with no escape? They call it an antinomy, a paradox where both paths seem right, yet neither leads to certainty. Kant, the master of time's mysteries, believed that just thinking about time could trap humanity in eternal debate. One side says time is infinite, a river that never dries. But another side argues that time must have a boundary, a starting point, and maybe even an end. Even Aristotle wrestled with this idea. If every moment is both an ending and a beginning, if every event causes something and leads to something else, then how could time ever stop? What would prevent the final moment from becoming the seed of another? And if you try to define the end of time, aren't you still using the very concept you're trying to escape? Richard Swinburne, philosopher at Oxford, claims that a true end to time is logically impossible. And if that's true, then the universe must continue. forever. So what would you choose? A world with a final chapter, or a story that never stops writing itself? What if infinity is just a glitch in the equation? When the Big Bang Theory emerged and black holes were discovered, it felt like we were finally grasping the universe. Big rip, big crunch, big freeze. Endless doomsday scenarios unfolded. But the more we understood, the more uncertain it became. Lawrence Sklar, philosopher of physics at the University of Michigan, once said, "The very theories that predict singularities also suggest they might not exist at all." According to relativity, everything in the universe was once compressed into a single point, with a size of 0. Black holes do the same, crushing everything into a spot where the math forces us to divide by 0. The result? Infinity appears. Not as truth, but as a warning sign. That maybe, just maybe, we've misunderstood everything. So what do you think? What if infinity is the first crack in our understanding of reality? When infinity shows up in an equation, it's not an answer, it's a warning. There are many kinds of singularities, places where infinity sneaks in, not always in the form of infinite density. Modern physicists, unlike Aristotle or Kant, don't run from infinity, but they still treat it as a sign that their theories might be hitting a wall. Take basic ray optics, the stuff you learned in school. It predicts that light from a distant source focuses into a perfect point, with infinite brightness. But in reality, light creates a bullseye pattern. Intense, yes, but always finite. Because light isn't just a line, it's a wave. Likewise, most physicists believe cosmic singularities don't have infinite density, just very high. They think relativity misses something, a deeper layer of gravity or matter, that would prevent true infinity. So what do you think? Is infinity a destination? Or just a signal we've reached the edge of what we know? If time can truly end, then every moment we live is a fleeting miracle. Leave a comment, drop a heart, as your own tiny imprint in the vastness of the universe. And if you wish to keep exploring the mysteries of time, space, and existence, share this video and subscribe to the channel. Because every share, every subscriber, becomes the energy that keeps the story going. If time ends, the laws of physics fall silent. At the University of California, Santa Barbara, many physicists agree. Singularities mark the breakdown of theory. To understand what really happens, we need something greater. A quantum theory of gravity, still under construction. This theory leans on a key insight from quantum mechanics, that matter, like light, has wave-like properties. If that's true, then the singularity might not be a point, but a blurred bundle of waves, erasing the divide by 0 error, and perhaps saving time from total collapse. But not everyone agrees. Some physicists still believe time can end. Yet this raises a problem. All known physics depends on time, motion, change, cause, effect. A true end of time would demand a new kind of law, one not rooted in time, but built on timeless truths, like geometry and perfect structure. So what do you believe? Will time run out or evolve into something beyond time itself? What if the early universe wasn't a point, but a donut? Brett McInnes, at the National University of Singapore, proposed that based on string theory, the early universe may have had the shape of a torus, a smooth, symmetrical donut. Mathematical laws demand such shapes be perfectly uniform. But near a big crunch or black hole singularity, those laws break down. The universe could become chaotic, no symmetry, no smoothness, and more importantly, no symmetry in time. The end wouldn't just be the beginning in reverse, it would be something entirely different. Some physicists believe time never started and never ends. The Big Bang? Just a big bounce after a collapsing phase. And inside black holes, the singularity might behave like a tiny star, boiling, bubbling. If you fell in, it would be painful, yes, but your timeline might not fully end. Instead, you'd leave a mark in the faint light that future observers might still detect. If time has existed forever, why isn't the universe pure chaos by now? Supporters of an eternal timeline avoid inventing new laws of physics, but they face paradoxes of their own. Entropy grows over time. So if the universe has existed indefinitely, why is there still order? And if you fall into a black hole, how does light carrying your imprint escape its infinite pull? These aren't just physics problems. Philosophers have wrestled with them for centuries. John Archibald Wheeler once said, "Einstein's equation says this is the end, but physics says there is no end." Some conclude, science may never answer whether time truly ends, because the edge of time is also the edge of reason. Yet others, like physicist Gary Horowitz, stay hopeful. Quantum gravity can provide a definite solution. Perhaps time, like life, emerges from something timeless, something that organizes chaos into the structure of existence itself. What if time isn't a flow, but a structure? And when that structure breaks, time simply disappears. In this view, time doesn't come from outside. It emerges from within the universe. And like any complex system, what's built can break. When that happens, time doesn't end with a bang. It fades, like twilight. The first thing to go? The arrow of time. That one-way push from past to future. Since the 19th century, physicists have known time isn't inherently one-directional. The arrow we follow is just matter, moving from order to disorder. Someday, the universe will reach heat death, perfect stillness, where nothing can become more chaotic, and all change stops. Clocks may still tick, but in both directions. The line between future and past will vanish. Some speculate time might even reverse, the universe tidying itself up. But for mortal beings like us, who live only when time moves forward, that reversal would be the end, just as surely as heat death. What if time still exists, but without time, as we know it? Roger Penrose, physicist at the University of Oxford, proposed a startling idea. Not only might the arrow of time vanish, but so could the concept of duration itself. In this world, we might still witness events in sequence, but we'd have no idea how long anything lasted. No seconds, no years. Only before and after, with no time in between. In the 1960s, Penrose, alongside Stephen Hawking, showed that singularities weren't rare. They're woven into the very structure of the universe. Penrose later argued that matter falling into a black hole ceases to exist in any meaningful way, and that, in a truly fundamental theory of physics, time might not play a role at all. In Cycles of Time, Penrose explores the early universe, a chaotic swarm of particles. Perhaps what we call time is merely a shadow cast by temporary order. The early universe was like a box of Legos spilled across the floor. A chaotic mess of quarks, electrons, and elementary particles. No atoms, no molecules, no binding forces yet. And so, there was no time. The first real step came about 10 microseconds after the Big Bang, or the Big Bounce in some theories. That's when protons and neutrons formed, each made of 3 quarks, barely a femtometer wide. Before this, there were no stable structures, and without structure, there can be no timekeeping. Clocks need reference, like the swing of a pendulum, or the size of atomic orbitals. But in this primordial soup, no such references existed. Even quarks and electrons, the so-called building blocks of matter, have no clear size when examined up close. They appear as nothing more than dimensionless points in a storm of chaos. If time can truly end, then every moment we live is a fleeting miracle. Leave a comment, drop a heart, as your own tiny imprint in the vastness of the universe. And if you wish to keep exploring the mysteries of time, space, and existence, share this video and subscribe to the channel, because every share, every subscriber, becomes the energy that keeps the story going. If nothing can measure time, does time still exist? In particle physics, the only thing resembling size is the Compton wavelength, a quantum scale that's inversely tied to mass. But before 10 picoseconds after the Big Bang, mass didn't exist yet, and neither did that scale. Roger Penrose explains, without anything to mark regular intervals, whether attoseconds or femtoseconds, time has no meaning for particles in the primordial soup. And this scenario doesn't just describe the distant past, it might mirror the distant future, when all stars have faded, when black holes have evaporated. The universe will be left with only massless particles, like photons. No structure, no clocks, no time. Even in a final collapse like a big crunch, clocks wouldn't survive. As philosopher Henrik Zinner-Nagel puts it, if time is what's measured on a clock, and there are no clocks, then time does not exist. If the early universe had no time, and the distant future has no time, could they actually be the same place in a grand cosmic loop? Not all particles in the far future will be massless. Some electrons may survive, and we could build clocks with them. Penrose knows this, and admits it's a flaw in his theory. He also asks, if the early universe lacked scale, how did it expand, cool down, and thin out? But if his theory is right, it leads to a stunning conclusion. The Big Bang and the end of time look almost identical. Both lack clocks, structure, measurable scale. Penrose boldly proposes, these are just 2 stages of a grand cosmic cycle. When time ends, it loops around to become a new Big Bang. The man who once argued that singularities mark the death of time now may have shown us how time survives. Even if duration fades, even if attoseconds and femtoseconds blur together, time isn't erased, because it lives on, in the unstoppable sequence of cause and effect. What if time was never time, but just another dimension of space? This idea dates back to the 1980s, when Hawking and Hartley proposed that the Big Bang marked the moment time and space split. Inspired by string theory, which suggests our universe is a membrane floating in higher dimensional space, they imagined our world as a leaf drifting in the wind. We, like caterpillars on that leaf, move freely within our 4-dimensional prison. But if the leaf shakes violently enough, motion itself becomes impossible. Progress would require moving faster than light, modding something physics forbids. From an external view, our timelines don't end. They curve, becoming paths through space. In this scenario, the universe stays four-dimensional, but all four become space. Objects accelerate, closer and closer to the speed of light, until time simply disappears. And perhaps the strangest part? We wouldn't even notice, because all clocks would slow, then stop, and we'd never realize that time had quietly slipped away. As time fades, we might not notice its absence. Instead, we see the universe accelerate. Galaxies appear to speed away, a motion astronomers attribute to dark energy. But what if this acceleration is time transforming into space? Even when we lose duration or causality, we still place events on a timeline. But even that final vestige of time might not survive. String theorists now explore black hole singularities using a bold idea: the holographic principle. Just as a flat hologram creates the illusion of 3D depth, our universe might be a projection from a complex quantum system. But not every pattern can make a hologram. Only precise quantum regularities produce dimensional space. If order emerges, a dimension appears. If order collapses, that dimension disappears. Fall into a black hole, and not just time, but space itself begins to melt. A star, which seems three-dimensional to us, may be nothing more than a pattern on a flat 2D system, according to string theory. As gravity intensifies, the flat system vibrates violently, and when a singularity forms, order collapses. Like an ice cube melting into water, the third dimension dissolves, and time follows. If you fell into a black hole, your watch would spin wildly. Time would stretch or collapse depending on your distance from the collapsing spatial dimension. Eventually, your watch wouldn't make sense at all. Space and time no longer act as a framework. Objects seem to be in multiple places at once, teleporting, without crossing the space in between. And even the imprint of an unfortunate astronaut who crosses the event horizon might escape back out, because when space and time vanish, so does the horizon. We imagine singularities will be replaced by something neater, but the truth is more unsettling. It's space and time themselves that are unraveling. Even when theory removes the singularity, it still assumes one thing: that time remains. Scientists now seek a theory that doesn't require time at all. But until then, time persists, stubbornly, haunting physics like a ghost. To reflect on the end of time is to reflect on our place in the cosmos, because what time will eventually lose are the very things we need to survive. A direction to evolve, duration to grow, scale to build, causality for change, and spatial gaps to carve out order from chaos. As these fade, so does our ability to thrive, and we're not just witnesses. We are participants in time's destruction. We live by turning time into death. And that is the final paradox. If you want to continue discovering untold mysteries, don't forget to subscribe and ring the bell, because the next video might change the way you see the universe.